In this case, you've been given a vector-valued function, which means this function of time is really an x and a y as a vector. And they want f prime t and dy dx. And so the important thing to realize is these are not the same thing. Dy dx is the slope, and we would find that by doing dy dt, over dx dt. So in this case, we would have negative 2 over t can be written as negative 2 times t to the negative 1. The chain rule would tell us then we have negative 1 times negative 2 times t to the negative 2, or 2 over t squared. And as we take the derivative of negative 4 t to the 1/2, a little bit of good review here, our power multiplies the coefficient, so now we have negative 4 times 1/2 is negative 2, t to the negative 1/2, or negative 2 on top, square root of t on the bottom. We'll go ahead and simplify this. Two over t squared, square root of t, excuse me, I've done that before, times the square root of t, negative 2 on the denominator, so here we will have a negative 1 over t to the 3/2, and we could put that in radical form if we wanted. There's our slope versus f prime t is really just, in this case, another way to write the velocity vector. It's going to be in vector form as well. We've already done it, each component. Our x component is this negative 2 over the square root of t, and our y component was 2 over t squared. Each derivative we did to find dy dt and dx dt are reported in our vector value derivative f prime t.